let's assume that you already have SQL Server set up, and so just want to clear this for you. For those of you who are using the cloud service like me, I said you still need to install a client to connect to your database from your laptop, right? So for instance, I installed Azure Data Studio, which is from the client side. For the SQL Server, again, I used Azure services on the cloud, okay? But you have the option for like installing SSMS, like Microsoft SQL Management Studio, if you have a Windows. So if your OS is Windows, then you have the option to either use Azure Data Studio or SSMS as your client, okay? This is, for example, what I have here. So you see, this is the interface that you want to like run your queries and everything. You want to connect your database from here. Now your database is either installed locally on your computer, or in like my case, is stored on the SQL Server on the cloud here. So this is the Azure portal. Just as a quick review, you can use this service, especially because you're a student. You can do it as free. Even for people who are not students like me, it offers, I think, a month free trial, 30 up to 32 gigabyte of storage. It was 250 before, but it seems like they reduced it to 32 gigabyte. It's still more than enough for what we want to like cover in this class, okay? As I mentioned, even if you store like a table with millions of records, it is still in like megabytes of storage, not like 32 gigabyte is too much. And so I explained how you create your account. Then having that account, I said, okay, you can go like to your Azure Data Portal, like create a resource here. So you just click here, create a resource, and then just a quick review for those of you who were absent. Then here, you just have to provide some information. So here, just select the SQL database. So there are many resources available on the portal. So we are interested in the SQL database. And then here I explained how to do these settings so that this total cost will come down to $0, okay? So if you already like log in with your student account, you have the option here. So it will show you something like a student free account, something like that, which you can select that. If like me, you're not a student and you want to like use a free account, I already used it, but for me it was like my subscription. I made sure that I go, for example, to configure database, and then here I selected the most basic one, which was, I think, this one. Now it came to $5 USD, but it was $0 at the time, and I think it's because just I already used my resource for now. And a few other settings that I mentioned was that for you, when you're just do the setup here, there might show a message here that would you like to use like the free offer, and then you just select yes. And I'm actually going to also show you that just to make sure everything is clear. So this is actually the page that you will see at the beginning. So you see here, it asks you whether you want to like try Azure SQL Database for free. Please apply the offer, okay? As soon as you click on apply offer, the amount here will come to $0 USD. And whenever you see a $0 USD here, then you can like simply click review and create after you, of course, you set up username, password, selected your database and everything. So here, for example, you select your subscription. You just provide a name for database. For example, I provided ECS3421, DB1, anything, just a name that you like. Your server is like you provide a name for your server. again, any name that you like, just make sure to use lowercase for all of that. So this should be lowercase. And then here you don't need to do anything else. And again, as I mentioned, the only setting that you have to provide is going to compute plus storage, configure database, and make sure that you have used the free SQL setup. And then you click just review create. It takes like a few minutes for the deployment, 2 to 5 minutes, okay? And then you're done. So after you select your offer, you see you have to see something like this, okay? $0 here. When it's $0, you just click on create, review, and create. And then you will be redirected to a page like this, okay? And then it takes a few minutes until you see this message that your deployment is complete. And at this time, you can, whenever you just log into your SQL database or your Azure portal, you can see your server name so that you can connect remotely to your server. So for instance, if I go to my home page now, you can see that I've already created this resource. This is my SQL server and this is my database, right? So whichever I click on, I can see my server name. Why do I need my server name here? Because if you're using a client like Microsoft Management SQL Server Studio, if you're using, when I say SSMS, just to skip that long name of Microsoft, so either using SSMS or Azure Data Studio like me. So when you want to log in, so let me show you that. It shows you a page. Let me actually go here. Just don't want to like redo everything. Okay. So it's this one. So since I already explained, I just don't want to log out and log in again. Just as a review, you selected create a connection. You click on create a connection. Okay. And then when you create a connection, it asks you for some information. Here you have to provide the server name, your username and password. Your username and password is what you have created when you wanted to create your Azure portal, your account on Azure portal, okay? So you enter your username and data and password. For the authentication type, you select SQL login. And for server name, this is why you needed to have access to your server names, like the resource that you have here. Here is your server name, and just copy it, okay? Copy your server name, paste it here. So the only things that you need to provide is your server name, username, password, and then you have to trust the server certificate, of course, because it should allow you to connect to the server, that it means that you trust it. And what else here? Your database name, and then you just click connect. Sometimes it may ask you for, like, it shows you another page to just add your IP address. You have two options: either add your IP address the way that I showed you before. So just going to close this. So here, if you go to networking, show networking settings, okay? So here you can just add your client IP address and make sure that this is selected network, okay? That you selected this option. Then you can either add IPs here, or sometimes it gives you option to just add your Azure account so that every time you don't need to just like add the IP address, okay? And then you have to click this, save, and then you're all set. Let's say we are now in Azure Data Studio, and this just shows like the green circle here shows that I'm connected to my server. This is like after you connected, right? Now you want to like write a new query. So we already explained how to create tables, drop tables, or alter table. So these are basically all the DDL commands that we need. So whenever you hear like SQL DDL data definition language, it means just creating a table or altering a table structure or just dropping a table, okay? It's everything about the structure of your table. And so here, let's just drop the, so we can just expand your databases here. So I see that, for example, I created this database, right? So I created this one. Your name, like your database name, might be different. And if you just right click here, you can select new query and write your queries here. That is how I have like this window here. Okay. Now, here is your like the terminal part. Like you see all the messages. If you get an error or something, you see here. And then on the left side, under your database, you can see all the tables that you have created, all the views, and we will explain views and indexes today. And again, you can get more information on each table. Just right click, select top 1000. It's like just a select a statement where you can see all the data in your tables. You can either like even edit your data and so on. And what else? So we have created all these 4 tables last time. So just let's drop them. So does it matter the order that I'm going to drop the tables? Yes. So these are like the integrity controls that we want to explain today. So now, which table should I start with? So I had a student, instructor, enrollment, and course tables, right? And we talked about like tables having foreign keys and the ones that are like referenced by those foreign keys. And we said that, for example, when we want to create tables, we want to make sure that we first create like those parent tables first, right? And then tables with foreign keys that are referencing those tables. The same is true for when you want to like insert data, although insert I included in the DDL a slide. Insert statement is DML, that is data manipulation language, when you want to insert data into tables. That was just to show you some like real tables with data. That's why we use the insert statement. Now, for the drop, what is the order? Should I first drop the tables with primary keys or without without foreign keys? With foreign keys or without foreign keys? The ones without foreign keys. So I have to drop a student and instructor first. Enrollment first. So drop is the opposite. You have to first drop the ones with foreign keys, okay? Because if you first drop, let's say, the instructor table or a student table, okay? So let's see what happens. It shows you an error. Like if I say drop table a student, it should give me an error, and this is because there is a table in my database, course enrollment, with a student ID as one of its column as foreign key, and that foreign key is referencing to the student table. Now, if I drop this table, it means that there is another table enrollment in my database referencing to a student table that doesn't exist. So it shouldn't allow me to do it. Couldn't drop a student because it is referenced by foreign key, right? So let's drop enrollment first. Can I start drop by course? No, again, no, with the same reason, right? So just, is it like course enrollment or enrollment? Enrollment. And you can like write all of them together. As long as the order is okay, it's fine. So you can just write drop table enrollment, drop table course, right? And then with the instructor and student, if in the student table we have instructor ID as a foreign key, right? Again, we have to make sure that we first get rid of the student table. Drop table student, and this is because in the student table we had a column instructor ID referencing the instructor table. So we first drop this and then drop instructor. So hopefully it's fine. Yeah. So we could drop all 4 tables. If you just refresh your like tables here, like they all disappear. Now, we also explained how to create tables. Okay, so just do a quick review. Table, we always start with create table, and it doesn't matter if you use lowercase or uppercase. Okay, like I'm going to write lowercase now. It doesn't matter. Okay. Now, let's say I write create table. So again, which table should I start first? We have a student, instructor, course enrollment. And I'm going to explain what columns each table has. Let's say our a student table have a student ID. Okay. So we have a student with a student ID as primary key, first name, last name, major, and then we have course, right? And then because they had many to many, we said, okay, we have also the enrollment here. And here we had the course. We also had an instructor here. Now, here we have instructor ID, primary key, right? First name, last name. Let's say we also have the rank of the instructor. And for the enrollment, we have, because it is associative entity, right? So it should have the primary key of both. Like here we have the course ID as primary key, course name, maybe course description, and for this one, because it's associative entity, get the primary key of both tables. So this is a composite primary key here. Each of them alone are foreign keys referencing like these two tables, right? So student ID is foreign key in enrollment referencing the student. Course ID is foreign key referencing the course. Together they are composite primary key. We may also have a grade here. Now, we may have also relationship between instructor and a student, maybe. If like we have anything like advisor or something like that, or you can skip it. If, for example, each student may have only one instructor, they have many, and then we have instructors teaching courses here, right? So each instructor can teach multiple courses. Each course should be taught by at least like one instructor. And so this was what we have. And you know that if this is your ER model, how many tables should you have using this ER model? 4 tables, because you have 4 entities. So the tables are student, course, enrollment, instructor. Now, what are the columns of each table? The attributes, right? So for instance, if you want to like create a student table, should be student ID, first name, last name, major. Right now, the columns that do not have foreign keys. So for foreign keys, you can just see the relationship between your entities, okay? Now, for instance, as I mentioned, if you look at the enrollment, it get the primary keys of like those 2 tables that it's connected to as the foreign key, right? So a student ID and course ID will become foreign key in the enrollment table. So I cannot start creating like the enrollment table first, right? Can I start creating just one more thing. And for the course, we also have the instructor ID. Okay. I cannot also create course, right? Because it also has a foreign key, which is the instructor ID. If in the student table you also had like instructor ID, advisor ID, something like that, again, you couldn't create a student first because it also had foreign keys. Right now it doesn't have, okay? So we just create table student. Now, you have some column student ID, right? And your student ID is should be not null because it's your primary key, right? And you should also define your data type. So a student ID is, let's say, is integer and should be not null. And then we have a student first name. First name could be varchar, like, right? And 50 means that the length of your characters could be up to 50. And then last name, again varchar. I'm just randomly put like 50, okay? And then what else do we have? Major. Major is what data type? Again, we can have varchar, maybe 30. And let's put it 50, and then I wanna like alter it later for you. Then we have to also define our primary key, right? So primary key, again, it doesn't matter if you use uppercase or lowercase, okay? They're the same. A student ID. A student ID. Now, after a student, what table could I create? I can create the instructor table? Mm-hmm. Now, what do we have here? We have instructor ID, right? Let's say this is integer and not null. We have first name again. Does it matter that it's the same name as the student columns? No, it doesn't matter. And here again, team. And then we have first name, last name, rank. And 20 is enough. They could be assistant prof, associate prof. It couldn't go like more than 20 characters. And what is our primary key here? Instructor ID, right? And then we are done. Now let's go to the next table. Now I want to create course. Can I create course now?
I think so.
Yeah, because course has a foreign key instructor ID which refer to the instructor table. We already created the instructor table, so we should be fine. Let me zoom a little bit more. Now we have create table course. Now I have the course code maybe, and for the course code, let's say is all fixed, like 8 or 10 characters, then I can use simply char, okay? And it can include like alphabets or like numbers. I don't want it to be null. Course code, and then we have course name. And it's not null, it's not only for primary keys. You may want to like define it on any other column. Maybe I don't want to like my first name and last name be null too, okay? Just write not null here. And so I don't want any like a student without first name, last name. I also don't want any instructor without first name, last name. So again, not null here. Not null here. And then here we have course name and course code, course name, and what else do we have? Description maybe. Course description. let's put like 100 here. Room could be HR, don't know, 5. Let's put 10. And primary key. So now primary key is course code, right? So this one is course code. Do we have a foreign key in the course table? Yes, we have instructor ID, which is a foreign key. For foreign key, it's similar to, like when you want to define it, similar to primary key. Put it at the end and then write the name of the column that is your foreign key. So this is your column name, instructor ID, right? And then I haven't defined it though, so I just have to add it here, instructor ID. And you have to make sure, because instructor ID was previously defined in the instructor table, you have to make sure that you use the same data type. So here, instructor ID was integer, so I can't simply write char, varchar, or any other data type, okay? So I have to use the same data type integer here. And so this is integer, so we have foreign key instructor ID. Then you have to also mention which table this is referencing to, right? So it is references the instructor table, right? And okay, so you also have to mention which column. Now let's say in the course I want to like write it as okay, here keep it as instructor ID for now, and then I will explain later. Now, sorry. Okay, so this means that our primary key is course code. Our foreign key here in the course table is instructor ID, which references the instructor table. Which column in the instructor table? Instructor ID. Okay, now we're done. Now, the only table remaining is the enrollment table, right? So create table enrollment. Now, what are the enrollment columns? Because it's a composite entity, right? We have the course code, a student ID, and grade. So you have the course code. What is the data type of the course code? Char 10. Should I write not null here? You don't need, like, not necessarily. It's a foreign key here. And then we have a student ID. Maybe I want to like write it a student number here. It's fine. And then a student ID, the data type is integer. So again, I have to write integer here. And then we also have grade. As I explained before, for grade, it depends on how you store grades, right? For example, if it's like have decimal numbers, like for example, 95.50, something like that, then you want to like use numeric. So I'm using numeric data type. And then for the numeric, the first number, if I write 5, 2, so the first number is the number of characters, okay? So when I have like 90, when my grade is, let's say, 93.50%, this is 1, 2, 3, 4, 5 characters, okay? And so it includes also the dot. And 2 is just the number of decimals. If you want to like keep up to 2 decimal points, you put just 2 here. And then we have grade. Primary key. What is our primary key here? Composite primary key, right? So we have course code and a student number. Do we have foreign keys? Yes. Like we have 2 foreign keys. The first one is course code, which references which table? Course table, right? And so which column in the course table? Course code again. So the name of the columns in this case are the same. We also have another foreign key, which is a student number, right? Now, which table does it reference? to a student. Now, in the student table, which column? A student ID, right? And now, I think we're done. So just a review, we created the student table, a student ID, first and last name, major. We already covered. Primary key we defined. We defined the data types, not null and everything. Instructor table the same. We created the columns, not null, data types, and the primary key. We don't have any foreign keys here. In the course table, we define primary key course code. The data type are consistent. Instructor ID is integer here too, and this is also foreign key because it references the instructor table. And then the enrollment, we have the course code, which is chart 10, a student number integer, grade, and then primary key, foreign keys, so we should be fine. So just let's see if we don't get any error. It's fine. So we have created all 4 tables again, okay? So now if you just refresh your tables here, you see all the tables are created here. Now, another thing I wanted to just do a quick review is like, okay, now that we created the tables, we want to see how we can alter a table. So maybe after you created your tables, you realize, oh, in the student table, I also needed an advisor ID, okay? I needed to add another column. So you just use alter table, okay? Now your table name. Let's say we want to like alter table student. So alter table a student, and then be careful with the parentheses, commas, semicolon, okay? So in the alter table, you don't have, like for example, when you create table, you have like a parenthesis here, but now you don't have anymore. Now, let's say you want to add a column. What is the name of the column? Let's say advisor ID, okay? Advisor ID. What is the data type of advisor ID? Because it is like similar to instructor ID and we defined it as integer. So let's have like integer here. And that's it. This is how you create like a new column or add a new column to the existing table. And I also explained that you can alter a data type of a column. Okay, so we have, like for example, let's check the data type in the student tables. So if you just double click here, you can see all the information in your table. And this is super slow. So we have a student ID integer, first name, last name, varchar, major 50, and I decided, okay, most majors are less than 50 characters. Why should I like spend 50 characters length here? I want to like change it to maybe 30. Alter table a student again, okay, and then now I want to like alter the column data type, okay? So I write alter column major, and the data type was it char or varchar? Varchar 50, so I just write varchar 30. And so just like let's execute like these two and see if it works. So it's fine. So you can actually also double check. So I'm going to close this and then refresh this. Then open my student table again. So it changed the major to varchar 30, right? It also added the column advisor ID. Now you, yeah.
So what if we change the type of, for example, student ID, would we have to like change it in every table that has it as a foreign key?
Yeah. It should be consistent in all tables, yeah. So now we have created the advisor ID, but we didn't, because we didn't add it at the beginning when we were creating this table, we also didn't define it as a foreign key, right? But advisor ID should be foreign key in the student table. So you also have to add a constraint. So I already explained how we add constraints. So one constraint could be like foreign keys, could be primary key, could be like check like a specific columns ranging like in being in a specific range. So for instance, let's say in the student table, I want to add another column like number of years, okay? Or for example, if you are in the course column and you want to like add a constraint that all grades should be either A, B, C, D, E, okay? Then you have to add a constraint, check if grade is in A, B, C, D, E, okay? Or for example, you have like the age, the example we had in our slides, and you want like, okay, I want the age like less than something or greater than something. Now, let's say we have like this table, a student, and then I add a column, number of years, okay? I want to just show number of years, I mean which year a student is in. Like, is it in his first year, second year, or more? Now, I add number of years integer. So this is fine, right? Now, I want to also alter this so that I want to add actually I want to add a constraint here. So I write add constraint, okay? What constraint do we want to add? So I want to like, let's say these are like all PhD students, and I don't want any PhD students more than like 6th year, okay, in my database. We just want to make sure that they are all like in like less than 6th year. So just add constraint, and then you just write the name of your constraint. Like for example, you said check years, okay, any name that you want. And then because the type of constraint is check, okay, you write check here. If the type of constraint is adding a foreign key, you write foreign key here. So I write check, and then what do we want to check? Number of years less than or equal to 6, for example. So check number of years equal or 6. So we added another column to the student. Is it clear now? Can you see? Okay. So you want to alter the table student, add a column number of years, which shows which year a student is in. And then we want to add a constraint to make sure that this is less than or equal to 6. One of you asked me the other time when I mentioned like the constraint check, for instance, for the age, let's say age greater than or equal to 18. I think you asked me what if like we already had at the time that we add like this constraint, what if we already had like some values greater than, like in the age column, we already have some values greater than 18 or 20. What happens then? So it doesn't remove the existing one. So the constraint is from now on, okay? But you have to decide what you want to do with the like values that are greater than 20. You can like maybe delete them if you want, or you can maybe move them into another table. So that's up to you, what you want to do, but it doesn't affect them. Now, so let's run this. We get an error, invalid column name number of years. So let's remove this one first. Okay, so now that we created this, now let's check this. So we're fine. Now I also want to like add advisor ID as a foreign key. So we already added the column advisor ID, right? So now I can just alter table student, add constraint, check, actually not check, let maybe foreign key. That's a name. You can write anything. Just for like more readability, I write foreign, like FK for foreign key, advisor maybe, right? And then what is my type of constraint here? Is it check? Is it primary key? Is it foreign key? Is it unique? What is it? It's a foreign key, right? So you want to define a foreign key. So what do you have to write now? So you wrote add constraint, name of your constraint, foreign key. So you have to define which column is your foreign key. Let's say this is advisor ID. And as usual, when you like add a foreign key, you also have to mention which column it's referencing to, because foreign key is just to link the tables, right? So it should show which table it is linking to. So we are adding on the student table here, we are adding instructor ID or advisor ID, right? Now this advisor ID is foreign key, which means that this is linking these two tables, okay? This is how these tables are linked through the instructor ID, okay? Because this was your primary key here, that will be your foreign key. The instructor ID is the same as advisor ID here. It doesn't matter that they have the different names. When you're defining them in the student table, you just have to make sure that they have the same data type, okay? And now, because we are linking the two tables, we just have to mention that, okay, this is references which table, okay? References instructor, which column? Instructor ID. So we alter table student, add constraint foreign key something, any name that you want. Foreign key is advisor ID, which references the instructor table, and which column? Instructor ID. This line simply mentioned that instructor ID and advisor ID are the same. So this is the primary key in the instructor table and foreign key in the student table. And so I should be able to create it now, and then it's fine. So now if I refresh my tables again, okay, and then go to a student table here, I should be able to see that foreign key advisor is added as a foreign key, okay? So this is the constraint that you added. And so what else? And we dropped the tables we already covered, right? So do you have any questions so far about creating tables, about dropping tables, or about just altering the table, like adding a column, changing the data type, adding foreign keys? Yes?
Can we, under the ALTRE, can we add multiple lines, or no? Each time we have to say ALTRE table?
Yeah, I already created the first ALTRE comments that I mentioned. I used 2 ALTRE. It worked for if I add, for example, ALTRE table, I added 1 column and then I changed a data type of another column. But if you write ALTRE column, for example, add a column and then you want have it as a foreign key, then it doesn't work. So you have to first add the column and then write the other one too. Just yeah.
So sorry, if we change the type of a primary key that's foreign key in another table, does it matter in what order for changing the type?
So you mean you change the data type of, for example, instructor ID in the instructor table, right? And then you want to change it also in the student table, the data type. So it doesn't matter, you mean, does it matter which one to change their data type first? I don't think so. We can try. So let's say in the student table, in the instructor, which one do you want to update first? Maybe the data type of instructor ID in the student table first. So let's see if we can. So alter table student, alter column instructor. No, actually it was advisor ID here. Advisor ID. Now we had integer. Maybe you want have it char. Let's see if it shows up. It shows us some errors. Char 10. Okay. Yeah, it gives you an error because it has advisor ID is referencing to the instructor table. So instructor table in this case is the parent table. So back to the slides. So we have already covered these. Says, and then if we have time, we go back to SQL again. So I'm updating the slides to show the screenshots of Azure Data Studio because I'm using it in the class. And so some of them I didn't upload it yet on the e-class because my updates are not completed yet. I haven't decided to put both SSMS screenshots and Azure Data Studio or just one of them. So I haven't decided yet. Just wanted to come here, make sure which one you're using more, and then decide what I want to put here. So far, I just added some screenshots from the Azure Data Studio, and these are from the SSMS, just to show that they are almost the same, okay? So the SQL statements are still the same. Maybe just some, like a few minor things change, like from one DBMS to another one. Now, what is SQL view? You can think of SQL view as like the result of a query, okay? The result of a select query in SQL that you store in a virtual table. It's not a real table storing data by itself, okay? It's just like a virtual table that give you or just representing the result of some queries. Let's say, for example, you have like this table 1 here, table 2, table 3, and 4, okay? Maybe like more tables. And then you constantly are doing some queries, joining like several like tables. And you do it a lot in your database. So it takes a lot of time every time. So what you want to do, maybe like creating a view, which is a virtual table, store the result of like this query that frequently I'm using into that. It speed up my process every time. Instead of like doing the joins every time, you do it only once, store it in a table, and then use it, just use that virtual table whenever needed, okay? So this is the main idea of a view. So you can think of it as a window through which you can see your SQL tables, okay? Not a real table. And so this is how you can actually define a view. So you just write create view, and this is the name of your view. And then you just write as, okay? So these are just the keywords, create view as. And then, as I mentioned, view is just the result of a select. You can think of it as a result of a select statement. You write, for example, select star from this table, join the other table, join the other table, and then put the result into a view, okay? So that next time, instead of querying all these tables, you just query your view, right, directly. And so you can use view for data retrieval as a virtual table. For example, if you want to like find all the students whose grades are, for example, A and enrolled in a specific year or like major, and then you can store them in a view, okay? So this is, for example, a very simple view just for demonstration purposes that is storing like good students in one view. And a view doesn't have a data of its own, so I said it's not a real table, okay? And it's like a window to view the data from other tables. So you can think of what are the differences between the table and view right now, okay? So what is the difference? I just mentioned. Yeah, so a table is a table with rows and columns. Is a place to store your data, right? But view is just the result of a query that we decided, for like many reasons, we decided to like put it in a view so that we can it provides us like easier access to our data instead of like querying and joining like multiple tables every time. It's specifically useful when you are like using some queries or some tables frequently. Okay, and okay, what else? So this is just what I explained. So the advantage is that it can join data from several tables and put like the result into just one single view or virtual table. So for example, you have a database with salaries, okay? And then you want to just like do some complex statistical queries on like these salaries table every time. So instead of like writing that complex query each time, if you're using it a lot, then you can just write it once, save it as a view. Okay, you just write create view complex query as, and then write your query, whatever it is, and then you like simply created your view. It's just like a saved select statement. Now, another important thing I want to mention today is indexes. So index, I like briefly mentioned before that we have indexes for like mostly for performance. So for like having faster queries to speed up like the queries. And so today we are going to explain how creating an index on a specific column actually make your queries run faster. Now, fast and optimized for quick lookups consume extra storage, and you will also understand why it consumed extra storage. And so data access doesn't depend on the existence of an index. Now, let's explain this. So when you have a table that is not indexed, okay? So when you want to like query an unindexed table, so for example, the table that you see here, let's say you want to like searching through the rows to find like the company ID 18, okay? So you're interested in only like company ID 18. So when your table is not indexed, when you have not defined an index on this column, what happens is that when you want to like have like this query, it search every rows to find the company ID 18. So how many like rows does it search to like retrieve, like in this example, how many rows does it search to find like company ID 18? So how many do we have here? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? 11, 12, 13, 14, 15, 16, 17. So we have 17 rows, and you can imagine in a large table, it could be like thousands of rows or millions of rows. So it is like searching millions of rows to return only like 4, 5, or like a few rows. Now, what is the solution? Like defining an index, especially for the columns that you are using in queries a lot. So if you are querying a specific column a lot, then it makes sense to, and if your database is so large, so it makes sense to define an index on it. So it just add a data structure as you see here with columns for the search condition that you have and a pointer. So for example, here on the company ID and a pointer. Now, what is a pointer? Pointer is just the address on the memory disk for like that row, okay, with the rest of the information that you have. Now, it's just to like give access to that specific row. So here are, for example, your pointers. Here's company data. Now this time, because you have created the index, now when you want to like search for example, company ID 18, okay, it just access them by the pointer. So it only access those 4 like or how many rows that you're searching for, and then retrieve the data specific to those rows. So it is clear why it keeps more space, right? So it needs extra storage because you want to like have the column where you have your condition on. You like want a space for your pointer, right? So it needs extra storage, but it makes queries much faster. So instead of searching for 17 rows, how many rows does it like search now? 4. 4 versus 17 in this small example, but it could be 4 versus millions of rows. So is this clear? Index? So this is like a very simple but important concept. And how do you create index on your tables? Easy. Just create index, your index name, whatever it is, and then you want to define which column on which table you're defining your index, right? So you have to write on, for example, I want to like create index on the product description column in the product table. And now we also have a unique index. So I'm going to explain the difference between index, unique index, and then also with primary keys in like a few minutes. But for now, just know that unique index is like an index that should be unique. For the index alone, it doesn't have to be unique. So, but when you define it as unique index, then it should be. Now, for example, you want to like create unique index on products. Make sure that this is unique, okay? And create unique index, for example, something else. These are just the name of your indexes, okay? On, for example, the table supply, on, for example, these columns, or if you want to like just drop an index, you write drop index with the index name. Now, what are the differences between, I want you to think about it. What is the difference between the primary key and unique index in SQL? Yeah.
I think primary key is like in the same table, but index is like another table.
No, you define the, sorry, maybe I explained it in a wrong way. When I was explaining the index, I wanted to explain why it needs extra storage, so you thought it's a different table. But we are actually creating an index on that table, okay? On a specific column on a table. So let's say, for example, you have a primary key in a table and also you have a unique index. So I changed my question. Does a primary key implies a unique index? If a column is primary key, is already a unique index?
Yes.
Yes. I mentioned it before, right? But the opposite, the difference is that the opposite is not true. If a column is unique index, it is not necessarily like a primary key, okay? So we define primary key as a column that can uniquely identify each row, right? We said that primary keys cannot be null, right? Now I ask you a question, can a unique index be null? Yes, it can be null. So that is one difference, okay? And another difference is that we can only have one primary key. Even if it's composite primary key, we only have one primary key. But you can define unique index on multiple columns, okay? This is another difference of unique index. Of course, as I mentioned, if a column is primary key, it is also a unique index, but we can have many more unique indexes on like a very large table with like hundreds of columns that are not primary keys. We only have one primary key, right? But we may have we may have many columns as unique index. And so I provided a link here. I think it was very helpful for me when I was first confused about like these concepts. So I highly recommend you to like read. I think one of them was from Stack Overflow, clearly explained the differences between index, primary, like unique, and all of these. And So last thing I want to explain today, maybe we practice it more next session, is about data integrity controls. So I tried to introduce the concept of integrity, referring like to integrity several times when I was explaining the data modeling, so that the terms get more familiar to you, and also the concept, so that you don't get panic when I explain it now. So it just refers to the accuracy or validity of the data. So what does that mean? First of all, I want to mention several things. If you remember when we were like explaining data modeling, and then I was explaining, for example, first, second, normal form. Do you remember the normalization? I mentioned, for instance, for a table to be in the first normal form, we want atomic values, right? We want, for example, no duplicated values. We also want data types to be consistent, right? So the first type of integrity control, which is a key restrictions, are referring to these types of restrictions. For example, not null values, okay? Or for example, the columns that must be unique. Anything, any constraint on the keys, okay? And then we have domain restrictions. For example, domain restrictions are about the format or like the range of the values. For example, you want like for values of a specific column being in a specific range or being in a specific format. And finally, referential integrity or cross-reference restrictions about valid foreign keys. We already explained it a lot about foreign keys. So we are going to see more with the examples. So we have entity integrity, which means that no part of the primary key can be null, okay? So if you have a primary key, it should not be null, okay? So that's the first thing. And second, primary key should be unique, right? Third, specify primary key or define a unique index over that key. So when you either have like that or a unique index. And add constraint for the attribute value restriction. So forget about this part for now. We'll explain it later. And referential integrity. So here, for the referential integrity that I'm going to explain today, we have three types. And it's mainly about like what happens if you delete, like update or insert a column that is a foreign key, okay? So for instance, because basically foreign keys are the common column between two tables that are related to each other, right? We said that we use foreign keys to link tables together, so they represent the relationship between two tables, and they are also the columns that are common in like both tables that they are connecting to. Now, insertion integrity means no row can be added into a dependent table unless the foreign key match a primary key in parent table or the foreign key value is null. And I'm going to show you with example. Update integrity specifies what action happens to the row in the table if those rows have a referential integrity, that is, they are like foreign keys in another table and you're updating them. So what happens, for example, in the primary table? If you're, for example, you update department ID, okay, in the department table, what happens to the department ID in the instructor table? So let's say you have several departments, ECS, I don't know, business school, so on. So we have several departments here. And then you suddenly decide to remove or delete one department, okay? So you remove the ECS department. Now we have several instructors, several professors working in that department, right? So what happens to them? You have to decide whether you want to like restrict that. So as long as there are employees working in a department, I don't want to be anyone to be able to remove that department from my database. That means restrict. It can be like cascade, which means, for example, okay, if you did certain updates, delete anything on a specific column, I want it to be reflected on that column too. Okay, this same thing. If, for example, you remove the department here, all, for example, departments from like the other table should also be removed. But it also should make sense. For instance, the example that I mentioned, if you remove a department, you most probably don't want to allow it happen if there are employees working in that department, right? And so this page is just explaining that, and then we better understand it with examples in the next slides. And deletion integrity means what action happens to rows in the table if those rows have a referential relationship, which means that you can, for all of these, when it's a referential relationship, you can consider or imagine two tables, okay, with foreign key in one linking to the other table. So it could be instructor, a student, connecting through instructor ID. It could be product order, connecting through, for example, order ID, or like anything like that. So this is what I explained. So we have different types. Restrict, which is the default, which means no action. I don't want the departments in my employee table to be removed. If I have employees working in several departments, I don't want to remove the departments, okay? So that means like restrict or no action. If you don't do anything, if you don't define like these restrictions, the default is this one. Cascade means forwarding, like the name, as the name implies, just forward or cascade the action in one table to the other one. So for example, if you delete or update anything in one table, it also cascades that into the other table. We have also another option is to set null or set to default. So I'm also explaining this. So for example, if you decided to delete or update department in the department table, maybe you don't want to you want to remove the department, but you don't want to remove everything in the employee table, employees that are working in that department for now, okay? So maybe you decide to set it to null for now, so that in the employee table you may have something like that. So you have employee, for example, Mona, working in department, for example, ECS, and I don't know, Alex working in business, and I don't know, Hannah working in, for example, ECS again, okay? Now, if you delete ECS from the department table, okay, so you have department table, ID, name, for example, you have ECS here, business, maybe you have math, and so on. And then you remove or delete the ECS department from the department table. I said if you do nothing or select the restrict, it means that it doesn't let you do it, okay? Because you have employees like Mona and Hannah working in that department. But maybe you use it like for set null or set default, which means you just put null here, okay? Or having a default value and set that department value here like that. So let me show you how it works. So for example, as I mentioned, if a department is deleted from the department table, all its employees, in this case, what happens to the employees? We define it as on delete cascade. So if I delete a department, what happened to the employees in that department now that I selected on delete cascade? Yeah, it cascades all that into the other table too. So all the employees will be deleted from the employee table too. And what if you don't define it here, you don't mention anything? Like, for example, the way that we created our tables so far, right? We created 4 tables today, but we didn't specify anything. When we defined the foreign keys, we didn't say, for example, on delete what happens, on update what should happen, right? If you don't specify that, like the way that we did today, the default is no action or restrict, okay? So it means if you didn't define undelete cascade here and you deleted a department, it doesn't let you to do that because you have employees working with that. On update set null, what happens? If you update a department, let's say you update EECS to, I don't know, electrical engineering, okay? You update the name EECS to electrical engineering. What happens? We said on update set null. So in the parent table, it just set values to null. So here on delete restrict means if you delete, it should restrict it, right? It shouldn't let it happen. So if an employee is working in a department, that department cannot be deleted. So for example, here, can we delete department ID 1 or 2? No, because we have employees working in those two departments. Can I delete department 3? Yes, because no one is working there. Undelete cascade example. So we have employee department again, deleting like record 1. Now I selected undelete cascade. Cascade means it cascades everything from the child to the parent, right? So for instance, if you delete the department ID 1 here, in the other table that it is connected to, that is the employee, wherever the department ID is 1, that row is completely deleted. So the result of employee will be this. So you may be very careful with the cascade, especially with delete and update. You don't want to like this happen. And undelete set null, that's a more logical option, right? This is more reasonable. If you want to like delete department ID 1, you want to still keep your employees, right? So in this case, you set null to the department ID here, right? You will still have your rows, you still have the employees information, you just don't have the department information. Or you have update cascade. For example, you change the department ID 1, change this, update it to 8. So what do you want to happen here? Okay. I think we have to leave soon. So if it's update cascade, means that whatever update that you have here should be reflected to the other one too, okay? Do you have any questions? So we are done for today.